Hey, how you doing? Tron Tech here. Welcome back to the show again. So let's get into the more illuminating part of this circuit, the LEDs. Now the LEDs are connected up in a particular configuration, which oh, sorry, that's not the right screen. That's the other screen. There it is. So the LEDs are actually configured in this particular way right here. The LED has an anode, which is currently on each one of these on the right-hand side, and a cathode, which is on the left-hand side. The anode is powered on by VCC, which is our 3-volt battery source, and then the cathodes are all connected up to resistors R11, R12, and R13. These are what we call current limiting resistors. Now, in a nutshell, LEDs are sort of one-way devices for electricity. If the higher voltage is on the anode and the lower voltage is on the cathode, that's what will eventually help to send current down through the LED. But if the higher voltage is on the cathode and the lower voltage is on the anode, then the LED effectively stops any current from flowing through until it breaks eventually with a large enough amount of a difference in the voltage between there. But LEDs are also sort of uh, tollways. They take a certain amount of voltage to be able to allow current to pass through. Depending on the LED that you're using, it will have different voltage values. Some LEDs, for instance, like red LEDs, can take as much as maybe 1.2 to 1.5 volts. They use that to allow current to go down and through it. Other LEDs, like blue LEDs, for instance, take larger amounts of voltages, anywhere between like 2.5 to 3.2 volts, to be able to turn on. And every LED is a little bit different. You want to look for what's called the forward bias voltage, is what it's effectively called in the technical definitions. But the forward bias voltage is what the LED takes. Now, after you give it the forward bias voltage, the more current that you send through it, the larger the brighter the LED is going to produce in terms of its illumination value. It's oh gosh, what's the right way to phrase it? It's bright, not its brightness. That's not the right phrase. Its luminosity might be the scientific way of being able to phrase kind of what that is. So the only way that I have a control value in my circuit for that is the current limit resistor. So the larger the resistance happens to be, the more that blocks some of the current. So basically, the smaller the value of resistance, the brighter the LED is going to be when it turns on. Now, I don't want to just have that set at nothing, because that will effectively, if R11, R12, and R13 were 0 ohms, they were just what we call short circuits, that may potentially be a large enough amount of current that would actually just fry the LED outright, which I don't want to have that do. Each one of the LEDs is connected up to a net list value, LED1, LED2, and LED3. And LED1, LED2, and LED3 are connected to my LM324QT on the outputs. Now, the LM324QT is being configured in such a way that it is sinking the current down into the outputs. The outputs are not just outputs going one way, they are also, the outputs are effectively able to take power in or deliver power out. They are bidirectional, so to speak. They can, or what we would call sourcing and sinking. They can source power going out of them or sink power going into them. When they source power going out, they're only able to output 2.3 volts, and the LEDs need some of that voltage to be able to turn on. So I have configured them inversely so that they are sinking power going into them, effectively using 3 volts down to 0, because when the outputs are when the values of the inverting and non-inverting sides are such that the output is effectively grounded, that means I've got 3 volts down to ground, and that effectively makes my LEDs a little bit brighter. At some point, I'll demonstrate this with a series of circuits where one of them is an output, the other one is an input, and you can see kind of what that is. So, effectively, what we're going to solder on today is going to be the 3 resistors here, R11, R12, and R13, along with the 3 LED values, LED1, LED2, and LED3, which I've got. I'll be using 120 ohm 0603 components for the resistors, and then for the LEDs, this is kind of an interesting thing. Where am I here? There I am. Hi. That's what we soldered on. Kind of the last time with that. Here is where all of the magic is going to happen. I have a. Hi. How are you? You just kind of hanging out there? You having fun? What are you? Are you? It doesn't even say. It's one of those, probably a jumper resistor is what I would have to guess what it is. LEDs are what we would call moisture sensitive devices. When we get LEDs, when we order them in, they actually come in a bag like this. Now I happen to have the amber color, the yellow colored LEDs that are still wrapped up in the bag that I bought these on from DigiKey. So I thought we'd actually spend some time opening this up so that you can actually see what's on the inside of this bag. This bag is a static shielded bag, so there is a certain amount of moisture, or what we call it, not static, well, it's static shielded, but it's also a moisture bag. It is preventing moisture from getting in. LEDs, as you'll see, these discrete LEDs have a sort of an ampule around the LED, to where if there's too much moisture being able to get in, it will effectively break the shell around the LED, or worse, break the inside parts of the LED, which will make it just not turn on at all with it. To do this, I'm going to open this up. I'm going to open this up. Ironically, I don't have a pair of scissors, so I'm using an X-Acto knife. Kids, don't play with X-Acto knives. Ask your parents before you play with knives or anything like that, because I don't have a pair of scissors. So I'm going to open this up kind of just by cutting it open live here on the camera. Ugh, can I do that? Gosh, my X-Acto blade is, there we go. Just had to find just the right spot for it there. So I'm going to open up the bag here, which tears open as such. I'm going to look inside. This actually comes with 3 things. It comes with a SCS moisture indicator is what it is. And I'm basically looking to see if the parts are on here. It says level 2 parts, baked parts, if that's at 60%. If 60% is not blue, level 2A through 5A parts, baked parts at 10% if it's not blue, and 5% of down here if this is pink. Initial use, do not put this card into the bag. If the 60%, this guy is pink, if the top one is pink, then we wouldn't want to do this. So this is effectively, this is kind of a measurement tool that measures how much moisture is actually on the inside of this bag, so to speak. So it tells me that the moisture of this is here. I'll leave this outside just to see, watch this kind of change colors to it here. You want to sit like kind of right around there? Is that okay? You want to sit there? You want to sit somewhere? Here, sit right around over there. That way everyone can kind of see maybe the blue color. The other thing that comes on the inside of this bag, in addition to hopefully the parts, I don't see where they are just yet, is a desiccation bag. This is a silica bag that contains some silicon powders that are on the inside that help to get the moisture out of the air and be able to trap the moisture on the inside of this bag is what it is. Specification, mil standard D3464 type 1 and type 2. So what you're basically supposed to do with this is put this on the inside of the bag, and if any moisture does get on the inside, this will ultimately get to it first. And then finally, the last part of the LED, and this one I think I ordered 10 with this one, so it's not a huge amount of them, but they come out and they are on a tape and reel strip, just like many surface mount components actually come in. They are on tape and reel strips, and you can see what they look like. That the tape and reel strip is actually on there right now. Can you all see that? You all see that there? Yeah. So let's take one of them out here. I'm going to move this out of the way a little bit so I can have at the top part of the tape and reel strip. I'm going to take the leader tape and sort of give it a little bit of a peel back on the embossed tape. There's 2 types of tape, and the one that LEDs tend to come on, it tends to be this embossed tape is what this is. So I'm going to take one of the LEDs out, and there we have it. There we have there we have one of the LEDs. Now what I'm going to do here is I'm going to put the bag off to the side, and I'm actually going to do the LEDs one at a time just to kind of demonstrate a couple of things while wearing a wrist strap as well, since we're working around with our product here. Let's show a little bit of polarity. I'm going to take my Fluke multimeter and switch this to the marker that's on there that looks like a diode is what it looks like. It's the arrow with a couple of bars with it on there. And I'm going to take my probes, take the caps off of my probes, and I'm going to touch the LED that is under view here. And I'll zoom in a little bit here so you can all see on the inside. I can see the dye on the inside of this. Now this is a yellow colored LED. So when I touch the 2 ends of this in with the red on my right hand, this is my red and this is my black, and I touch this, that is the incorrect way. Notice that the multimeter probably says OL or something close to along those lines to it there in this particular configuration. But if I switch my probes around to where the red is on the left and the black is on the right at this point here, oops, sorry, hard to kind of hold these guys into place while doing this here. You see that the LED, well, it's not, well, love to put that on the screen for you to be able to see that. Hi, how are you? So now the LED is actually turning on at that point. This is providing us with, and the multimeter is reading close to the forward bias voltage that it actually takes to turn this LED on. So let me try that. I'm going to try to hold this as still as possible so that I can actually look over at the multimeter. Can you tell me what that is? Oh, sorry, the LED is not, I'm not able to get the probes in such a way. I'm trying to look at my screen right now while I'm doing this. This should be around like 2 volts or something like that. 1.8 volts, yeah, 1.85 volts. That sounds about right for an amber colored LED. So the amber colored LED is here. And one of the things I noticed with the so the red probe was on the left-hand side, the black probe was on the right-hand side, and if you notice when I flip this over onto the bottom of the LED, I'll just grab the dang thing. Notice that there is a triangle when I flip this over at 180 degrees mirrored along the y-axis. The triangle is pointing to the cathode at this point. Now, on my circuit board for LED 2, the triangle should be pointing towards the cathode, and that is actually the marked part of my silk screen is what that is. That is the marked part of the silk. Oh, I lost my LED. Hello? You still there? That is the marked part of the silk screen. So when I attach this LED down to LED 2, the cathode is actually going to be pointed. Oh, jeez, I keep dropping all my parts. Now where'd you go? Is that you over there? Hi. Trying to demonstrate this. You want to... Is that you? Is that the right one? That's not the right one. Where'd you go? Did I lose you? Have I lost you? I probably lost you somewhere. Hi? Hello? I have definitely lost one of my parts, which happens when you're working with parts that are the size of fly poop. That just is naturally part of the deal. Oh, nope, it is way, way... Wow, you really kind of took a little trip, didn't you? Nope, that is not the... No, that is the right one to it there. So yeah, going back down to LED 2, I'm going to want to attach it so that the bottom part of the triangle is actually pointing up towards the marked part of the cathode there. So let me flip this guy over, and we will see that the this is sort of a difficult thing to really be able to do. So we'll flip it over and we'll see. Oof! Can you see that there? The triangle is going to be on this side. So when I flip this back over again, I want the die part of this to be on the bottom side of the board, which is actually what we are going to do right now while we are aware of what the polarity marker is going to be. So just so I keep it fresh, I'm going to put a little bit of some fluxing agent down. I'm going to take some of my soldering iron and my solder wire. I'm going to tin one of the sides of that guy there. I'm going to next come on over and come to the LED, and I want to be kind of cautious with doing discrete LEDs. I want to make sure that I don't touch the ampule as much as possible. That should be enough just to kind of tack the thing down. By touching the ampule, I could potentially pop the plastic part of the LED off of its the LED, the little plastic top part of it there. All right, and I'm going to touch this down to the other side here. Hi, is that you? Is that okay? Yeah. All right, that looks like it's kind of soldered into place. I'm going to do a double check with my multimeter to make sure that this has been done in the correct orientation there. And yes, it has, with the red probe on the one side and the black probe on the other. And I have my amber LED has been attached. So amber is good. I'm going to go put my parts back into the bag again, because a lot of LEDs tend to kind of look a little bit the same for the most part. I had somewhere, is that one of them? I think that's one of them. I have another LED. Now I believe this is actually going to be LED 1 is what this is going to be here. And I'm going to kind of move LED 1 over to this spot here. Now this LED is a little bit different. This has on the bottom part of it here a T that is pointing towards the cathode. which is typical for how these guys tend to look here. But unlike the very bright colored King Bright LED that I've got on the for LED 2, LED 1, more or less, you can actually, if I turn this in just the right way, in fact, here, let me turn LED 1 so that you can see it kind of in the left to right orientation. If one were to look very carefully at this particular LED, gosh, I'm going to put down a little bit of some fluxing agent because my tweezers have fluxing agent on them too, and this is just going to kind of help to hold things into place. There we go. If one were to look very carefully at this LED, one would notice that there is a green marker, which you can't see there, but you can see right there on the top part of it right now. That's a kind of probably really tricky to see where that's at. I'm gonna turn up the gain just a little bit here to see if that helps with anything. Let's see here. And then focus up to the top part of the LED, and there is a tiny marker up on the top that helps us to be able to see where that polarity marker happens to be at. I can see it fairly easily from here. There's a little green bar that's kind of up on the top. It's barely visible, and much easier to see with the use of a microscope. So let us do a little bit of a tinning process here. I'm going to come at the fluxing agent, which is currently on the pad, and that has actually been nicely placed along with that LED, so that sticks it there. And I'm going to use the rest of the flux that's on the other side here to tack down. I got a little bit of a stalactite, but I'll fix that here. And then test this LED. This one might be orange instead of red, but that's okay. Is it right? Yeah, so it's a little bit of more of an orange color is what it is. It's definitely a different color than there, but I have configured this in the correct orientation. So there is now an orange LED that's been lit there. And the final one that we will put down should be these green ones that I've got for here. Now I had one that was just sort of I literally have just one on a piece of tape and reel, and sometimes they come like this here. You see that? See that guy there? There's like literally one on a piece of tape and reel. So I'm actually going to take this guy out just to see. I suspect he's a green LED or a blue LED because the here, let me zoom out a little bit so you can kind of see what it is that I'm doing here. I suspect he's green or blue, and you'll see this here in just a little bit. The wires that are on the inside, there are two on the inside. Green, I've noticed that green and blue LEDs, at least the ones that I typically order, tend to have two wires connecting to the die on the inside. That's nice. It's got a little triangle on there. I'll put the plastic piece of the tape and reel off onto the side of it, and so the triangle is going to align up correctly for LED 3 to be able to be attached to that spot there. Let me turn my gain back down again so that you can kind of see where that's at. So yeah, that's the way that this is going to be attached to it. And let's start the attaching process here for LED 3. I'm going to put a generous amount of fluxing agent down. You'll see here in just a little bit as I flip this guy over and stick them into some of the tacky flux, which happens to be kind of all stuck down to this board here. There you go. And if one were to look very carefully at this LED, there are actually two wires on the inside that attach to the die that's on the inside part of the LED. It's how I kind of have an idea. Green and blue LEDs tend to have this more. Not saying I am an expert in LEDs. If there is an expert out there that's in LEDs, let me know in the comments if there's that's there for any really particular reason or anything like that. I've just something that I've noticed. Is that always there? Is that never there? Am I just kind of seeing things like as an amateur? It's probably what it is. I'll kind of stick that guy, put him into place there. That's kind of nice. That kind of all flowed very nicely down. And I'm going to take this other one, put it right here. There we go. Attach that, and now we'll do a final test for the green LED to make sure that he's in the correct. The red probe is here on my my right hand side, and the green probe is there, and voila, I get a nice green color LED. Those are all in the correct orientation. Now all I really have to do is kind of finish off the rest of the resistance resistors for the current limit resistors, and that's what those are called. The LEDs use what are called current limit resistors, and more often than not, if there is any sort of LED or LED array or something like that, there is somewhere in the mix of things current limit resistors that are just going to be somewhere there. Just one of those things that they are what they are to it on here. They are on that part of the LED. Just happens to be part of how LEDs tend to work. So I'm going to first tin all of the pads of R11, R12, and R13. So I've got some right here, some right here, and a little bit of a tinning right there on each one of those three. Very good. Now I thought I brought the three current limit resistors and just sort of slapped them down somewhere. I'm looking around for them. There's two of them. So I see there's one. All right, there's two. But I'm missing the third. Are you the third? You're sitting around upside down right now. So actually I'm not so certain. That says, well, that one says 131. So it's a little bit off. That one's 130 ohms, while the other two are 120 ohms. That's okay. We'll still work with you in the same way here. So 121, 121, and the red one, the one for the loud noises, or the orange one really. The orange one will get 131. There could be 121. All that means is that the orange one will be just a little bit more dim than all the rest of them will. Nothing too bad. I'm going to switch over to doing this in a left to right orientation. Actually, I'm going to switch over to doing it in a upside down left to right orientation because of the way that I put those chip resistors on. So now I'm going to, oops, can you see what I'm doing there? Can you see what I'm doing? Can you see? I have to probably do that a whole bunch of times, and I'm really sorry about that. In some ways, I'm sort of doing this for the first time to do it all via camera. A lot of times I'm doing this in a classroom type of setting to where I have some immediate feedback. But in the case of these videos right here, I'm sort of recording these videos before they go up onto onto YouTube. And so this is one of those I'll be constantly kind of checking back and forth between whether or not the video is actually capturing what it is that I'm doing to it right there. And this is something that for me might take just a little bit of some practice as well, of just being able to attach some components down while doing it the way that I'm doing to it here. So anyway, that's the three resistors are all tacked down into place, and now just a little bit of some solder on the end of it here. There you go. There's the one, and there's the two, and I've still got a little bit of some on the end of the of that chip there and there. Oh, come on, get attached. There we go. That's a little bit of a hat on the end of that last one there. Just a smidge. I don't know if you can see that on our. Here, I'll flip this around here so we can look at this in the correct way that these guys are. Oh boy! Hi, how are you? Jeez, boy, you are not a pretty picture. Let's clean you up. You look like a dog right now, and that's not the right thing that you really want to look like here. So let's start with R13 to make you. Gosh, that looks oh my. Is what that is. So come to this one here and this one here. That's awesome, the way that works. Yeah, we'll come to you here on R12. Same thing for R11 as well. R11 and R11. It's sitting a little bit pillowed up right now, but that's okay. It's in terms of it being connected up. All right, so we have all three of our LEDs as well as our current limit resistors that are all attached to it. All we really have left to do is attach the microphone and the battery clip, and this thing should be ready to roll. We'll see how well it works, and we'll do that over in the next video here. So thanks very much for coming on in and checking this out. Let me know in the comments what you think about this. Are you learning something? Is this intriguing? I don't know. So, let me know what you think about this, and we'll see you on what hopefully should be the one of the last videos. Sometimes with these projects, it never is. There's always sort of a troubleshooting part of it, but we'll see what that comes up with anything with this here. All right, folks. Thanks very much. We'll see you on the next one. Bye-bye.